Welcome to the TMC Newsroom. My name is Rich Tehrani. Thanks for watching us today. We're in San Jose all week speaking to some of the best and brightest companies in Silicon Valley. On our program is John Gilmartin, the Senior Director of Product Marketing at Coraid. John, welcome to the show.
Thank you, Rich. Good to be here.
So let's start off at the top. What does your company do?
So Coraid, our mission at Coraid is really to try and redefine storage economics. What we're trying to do is kind of like what x86 processors and Dell did to the mainframe. We're trying to do to storage. Storage is traditionally very expensive and complex. So we're using Ethernet to bring very massively parallel high-performance storage to the industry.
So is the differentiator that you're using Ethernet, or why don't you tell me all the differentiators? How's that?
Yeah, absolutely. So there's a couple trends that we're leveraging. One is Ethernet. So Ethernet is going right now 1 gig, 10 gig, 40 gig, 100 gig. It's going by factors of 10. Whereas Fiber Channel is really going 2, 4, 8, 16. It's growing pretty slowly. So Ethernet has hit a crossing point where you can get higher performance out of Ethernet than you can from Fiber Channel.
And it's cheap.
Yeah, and the pricing of that is very favorable compared to Fiber Channel, which is very proprietary and complex. The other big trend is kind of cloud and virtualization. So virtualization projects often are stymied by the cost of storage. So countless companies, they build ROI models saying I'm going to save a lot of money based on consolidating servers, but then they give it all back to the storage company because storage is so expensive. And at the same time, storage is complex because it's based upon these scale-up models, it's based upon proprietary architectures, and they're not really designed for the dynamic nature of virtualization and cloud environments, where virtual machines are moving from server to server, connections are constantly changing. Traditional storage grew up in the mainframe era where things are static and connection-oriented, and you have point-to-point connections between everything. So what we're able to do is leverage a very low-overhead, massively parallel data architecture and deliver massive parallel access to all the drives on the network through a scale-out architecture. So we can get better than Fiber Channel performance, but at 1/5 the cost of Fiber Channel using off-the-shelf hardware. The other thing we have is a distributed architecture, a distributed operating system that we call Core OS, that enables us to treat each of these building blocks as an entire system. So what it gives you is kind of the true cloud model, where as you want to grow your business, as you're growing users, as you're adding virtual machines, adding computing, you can grow your storage just in line with that. With these building blocks, we just add storage to the network, plug it into your Ethernet network, and grow storage just in line with your business. So it's scale out, it's price performance, a 5 to 8x price performance advantage over traditional storage, and at the same time, it's super simple. I mean, you can get these boxes attached to the network and set up in a matter of minutes. It's just compared to Fiber Channel, which takes hours, days, it's just dramatically simpler.
Now, what about the overhead of communications between all of these disparate systems and the controller and your operating system? Have you seen that there's overhead that slows things down at all or not?
Yeah, so absolutely. So if you look both at kind of Fiber Channel, which is a pretty heavyweight protocol, and even iSCSI, which is trying to use Ethernet as well, that's using TCP, which puts a tremendous amount of load on the CPU. And at the same time, again, requires you to manage all these connections individually and push data through a single path. We use a protocol called ATA over Ethernet. It's been in the Linux kernel since 2004, so it's an open standard, it's 12-page, super light, very low overhead protocol that gives you massively parallel access to every drive on the network. And it does that without, again, without any of the overhead of traditional protocols, and also removes a lot of the inner kind of network complexity. So you don't have things like port bonding, you don't have to do multipathing, you don't have to manage switch configurations and zoning. It's just standard Ethernet, and we just flood the network with data in a massively parallel way.
Are you partnering with a lot of companies right now? Like I'm just thinking of like the large computer companies.
Yeah, so we're kind of growing very quickly at this point. We're kind of growing 2 to 3x per year right now, and we're moving a lot into the kind of cloud and virtualization space. And so those are the kind of companies that we're starting to partner with.
Because you also compete, right? You compete with like an EMC and an HP in many ways. So I figured.
Right. So we're going to compete with the traditional storage vendors. So where we're going to partner is with the kind of the cloud and virtualization, the VMwares of the world, who are building software that really, right now, with traditional storage, is not you're not really realizing the full benefit, right? So there's countless stories. So we have one big customer in the Department of Defense. They estimated they were going to save $30 million with their virtualization project, but it turns out that they ended up giving $14 million of that back just in storage cost overruns, right? And so this is a huge problem, and it stops a lot of virtualization projects.
Now, does your technology also evolve RAID as well, so that you're not reliant on the speed deficiencies of RAID in today's world?
Yeah, so what we do is with Core OS, we take standard x86 systems, put disks into those systems, and then we use software RAID, so we can do any kind of RAID protection group that you'd want, and then stripe across disks or whatever. But we also have a storage virtualization appliance that allows you to do things like snapshots, clones, replications, and set up no single point of failure architectures, so that if any single component in your network should fail, you can still keep your applications running and accessing data.
One of the challenges with traditional RAID is just the time to rebuild the disk. It just slows the system down. I mean, so theoretically, those challenges are lessened with your architecture, or is it the same challenge?
So RAID is still RAID, and you're still kind of limited by the physics of spinning media.
Sure.
So that's still going to be the same thing, but by having kind of storage processing distributed throughout the architecture, it becomes less of a problem, right? Because it's scale out instead of having to the potential for a bottleneck, which a lot of people run into with a single big controller-based system. Yeah.
Thank you so much for your time.
Okay, thank you very much.